Hello, 7th graders. This is Mr. Humphreys, and we are now in section 3.8, Finding and Estimating Square Roots. Last year in 6th grade, you learned what square roots were and you applied them, especially in the Pythagorean theorem. We're going to take this one step further in this section and take your previous understanding of square roots and put it with irrational numbers, estimation, and also the other values of square roots that you could get. So let's start with a diagram. The first thing I want you to do is write down the number 16. Now, what is the square root of 16? Good, it should be 4. So you know that 4 squared gives you 16. But 4 is not the only number that if you square it gives you 16. What would the other number be? If you can't think of it, it's okay, but let's write this down. What number squared would also give you 16? Hopefully you figured out that it would be negative 4. 4 squared gives you 16. And negative 4 squared, remember it has to be in parentheses though, is also 16. Now if you take the square root of 16, that would give you 4 or negative 4. So you have to realize that every positive number has 2 square roots. That would be a statement that I think you should write down. Every positive number has 2 square roots. So here's your key concept. The number a is a square root of b if a squared equals b. So because we know that 4 squared equals 16 and negative 4 squared equals 16, we then know that 4 and negative 4 are square roots of 16. Something else you already know is that that symbol is called the radical symbol. That indicates a square root. Now these are some terms you might not know. The expression, for example, if I gave you the square root of 16, means the positive or principal square root. We just got done saying that a square root has 2 values. So the square root of 16 is 4 and negative 4. But if you see the symbol written as a square root of 16 as you do here, that means we're looking for the positive value, which is also called the principal square root. The expression negative square root of 16 means the negative square root of 16. The expression under the radical sign, so in this case 16, is called the radicand. You can use the symbol plus or minus to indicate both squared roots. So let's use these tips to solve our first example. So let's look at example 1. Simplify each expression. A, the square root of 64. That's asking for the principal square root, the positive value of this. So this is going to be 8. B asks for the negative square root of 100. So our answer is going to be negative 10. But then C asks for something called plus or minus, which means you want both square roots of 9/16. So plus or minus is how you'd read it. Plus or minus the square root of 9/16, that will give us 3/4. And lastly, the square root of negative 16. I know you talked about this briefly last year. If you punch this in your calculator, you're going to get an error. Why? I want you to be able to explain why. Now, right now we're talking about real numbers. So for real numbers, the square root of a negative number is undefined. We are not going to always write undefined because eventually we're going to start talking about imaginary numbers. So negative 16, if you take the square root of that, would give you an undefined real number. In the next example, we're going to actually find the square root. But then we also need to tell whether each expression is rational or irrational. So let's remember what irrational and rational means. Rational would be values that either terminate as a decimal or repeat as a decimal. So these two would be terminating or repeating. Irrational means you have a decimal, it can be turned into a decimal that does not repeat and does not terminate. So it would actually go on forever without repeating. A great example of an irrational number is pi. So let's go over these. The positive or negative square root of 81 is going to be plus or minus 9. Since that's a terminating number, this is going to be rational. B, the square root of 4/9 is going to give us 2/3. 2/3 as a decimal is 0.6 repeating. So 0.6 repeating repeats. This one is also rational. Negative square root of 5. If you took the square root of 5, you would get approximately negative 2.236 and so on. This does not repeat, but it does not stop. So this one is going to be irrational. And the last one, the square root of 1/3, gives you approximately 0.5773 and so on. That also does not repeat, but it does go on forever. So that number is also irrational. Your next key concept is to know that the squares of integers are called perfect squares. So if I wrote down some consecutive integers and I squared them, 1, 4, 9, 16, 25, 36, and you see the pattern. These are called consecutive perfect squares. So these are all perfect squares. For example, 10 times 10 is 100, so 100 is a perfect square. So we can estimate things by using these perfect squares. So let's use perfect squares to do example 3. Between what two consecutive integers is the square root of 14.52? So we have 14.52 underneath the radical. Now, we know that a perfect square, for example, if we look up here at the top, 14.52 is going to lie between 9 and 16. So if you took the square root of 9 and the square root of 16, which are perfect squares, it's between them. The square root of 9 is 3. The square root of 16 is 4. So we know that if we took the square root of 14.52, that is going to be between the two integers 3 and 4. So our answer is going to be between 3 and 4. So I want you to tell me on your own, between what two integers is negative square root of 105? So pause the video, do that yourself. Hopefully you realize the answer would be between negative 11 and negative 10. Because negative 11, if you actually took the negative square root of 121 and the negative square root of 100, 105 lies between those, so our answer will be negative 11 and negative 10. So in example 5, we're going to use a real-world formula that people in construction actually use. So this tower is like a big power pole that you see out in the middle of a field that has electric lines hanging from it. Now on this problem, I've already labeled all parts of this diagram. This red line, that's actually the wire. So let me read this to you. The formula, D equals the squared root of x squared plus 2x squared, gives the actual length D of each wire for the tower, which I show here. Find the length of the wire if we know x is 12 feet. So this is a formula that people in construction actually use. So let's take the 12 and plug it in. D equals the square root of 12 squared plus 2 times 12, which gives us 24 squared. So D equals 12 squared, which is 144, plus 576. We add those together, get square root of 720, which, if we approximate this, would give us approximately 27 or 26 and 8/10 feet. So we would actually say that the wire is about 26.8 feet.